Let's look at how to set up our tables for when we have multiple propositions. So in previous videos, they've been given to us, but let's look at kind of the nature of these setups. So we're going to have a truth table with two propositions, P and Q, and then we're going to have some logic stuff that comes after that. I'm not really concerned about the logic stuff. I just want to show how to set up the true false combinations for multiple propositions. So here with two propositions, you can really think of this in terms of a tree. So if we start with P, I know that P can be either true or false. And I want you to kind of think back about flipping a coin multiple times. So two propositions, let's think about that as flipping a coin twice or flipping two coins. So the first coin can be heads or tails, just like the first proposition P can be true or false. And then branching off from there, we're going to make a second determination for Q. The Q can be either true or false as well. So this is kind of like the idea of the second coin being also heads or tails. And so if we follow each path, the topmost path is going to be true, true. And so that's what's going to go in my first row. P is true and Q is true. And then moving down, I'm going to see that I could go true, false. So then I would have P is true, but Q is false. And then I could start on the third possible outcome, false, true. And then lastly, false, false. And so this is how the truth table for two propositions is set up. And it's easily scalable into three propositions. So let's have a look at that. So let's say we have three propositions, P, Q, and R. So and again, you can think of this like flipping coins. Let's say we have three coins now. So the first coin can be true or false, just like the first proposition could be, sorry, the first coin could be heads or tails. That's how I'm thinking about it. The first proposition could be true or false. And then I'm going to have my second proposition, which could also be true or false, and then my third. And so here we're creating this tree, and I can follow each path to get all possible outcomes. So I could get tails, tails, tails. So that represents tails, tails, tails for P, Q, and R. I could get tails, tails, false. So that represents P being true, Q being true, but R being false. Similarly, we can have TFT, TFF, FTT, FTF, FFT, and then the last one is where they're all false. So notice there's 8 outcomes here. And so that would be also the same number of outcomes if you were to flip a coin 3 times. So if we could scale this up to as many propositions as we want, but it's always going to be powers of 2 because we always have that true false binary in each proposition that we have. So this is 2 times 2 times 2.